In last video, we saw how to set up a cluster with Windows and Linux worker nodes using Flannel as a CNI. In this video, we will see how to set up a load balancer for our cluster. We will use MetalLB. In the second part of this video, we will see how to install and configure Nginx-Ingress. And in the third part, we will see how to manage SSL certificates for our cluster. We will use the Cert-Manager and we will issue some self-signed certificates for our web apps. We will continue where we left off in the last video. As you can see, we have our cluster. And we are going to start with the MetalLB installation. MetalLB is a load balancing solution for bare metal Kubernetes clusters. With that, you can expose your deployment to public network. If you are using AKS in Azure or EKS in Amazon or GKE in Google, you don't need to install an external load balancer. Because in those environments, when you expose a service as a type load balancer, it will automatically give you a load balancer. So in our cluster, currently we need a load balancer. For example, if we try to create one, like I do in here, I have an example of Nginx. And as you can see, the external IP will say at pending because it doesn't know what to do with that because we don't have any load balancer. That's the reason we need a MetalLB load balancer. So to install that, you need to go to the MetalLB website. And for the requirement, we need a Kubernetes 113 or higher. You need to check your CNI provider. For network configuration, we use Flannel, so it has a full support. You need some IPv4 addresses for MetalLB to hand out. I will use my router IP addresses. I will choose a few IP to use for a load balancer. And if you use BGP operation mode, you will need one router that is capable to speak to the BGP. And you need to open the port 7946 between your nodes if you are using the firewall. Installation is pretty simple. If you are using IPv4, you need to make sure to set the strict ARP to true. To check that, simply you can get the configmap. And we need to check the configuration for the kube proxy. And as you can see, the mode is not set, so we don't need to do anything in here. So there are a few installation options. I will use the kube apply. Here it will create the namespaces for the MetalLB. And the namespace is in there. And the second line will install the MetalLB. As you can see, the pods are created and they are running. So at this point, we need to create the config map. I've already created one in here. It's pretty simple. You need to specify the IP range that you want to hand out. This is my router IP range, and I will hand out 20 IP addresses in this range. So I'm going to download that and apply it. So the config map is created. That means our load balancer is now functional. If I check the deployment for the Nginx, as you can see, now we have an external IP, and through this external IP, you can access these services. So for now, I am going to delete this, and we will continue with the installation of Nginx-Ingress. Let's take a moment and see what we are going to build. We have a MetalLB as a load balancer, which handles the exposing of the services to the public. It will send the traffic to the Ingress controller, and depends on the host name. Ingress controller will send the incoming traffic to the services. There are quite a few implementation of the Ingress controller, like traffic, HR engines, and so on. In this video, we will use the Nginx-Ingress plugin. To install the Ingress, we have necessary scripts in the Ingress folder. It's quite easy. First, we are going to install Helm. If you want, you can also install it without the Helm. Yeah, you may want to check the documentation on the Nginx-Ingress. So the Helm is installed. Now we are going to add the repo for the Ingress-nginx and use the Helm to install it. You may want to note down this example. And to get the service IP, we can use this. And as you can see, Ingress-nginx controller as a type load balancer is there. And this is our public IP. That means if I call this IP address, it will be handled with the Nginx, as you can see. So the installation of the Ingress is done and it's working. Now we are going to test it with some web apps. The examples can be found in the deploy folder. First, we are going to create one simple namespace. It makes things easier when you want to remove it later. So the namespace is in there, and we are going to use the Linux web for the app. We are using this namespace thrall, and it will be deployed to the Linux nodes. It is deployed. Afterwards, we need a configuration for the Ingress. It's pretty simple. We need to set the kind to the Ingress, and in the spec section, we will specify the Ingress class name. It's Nginx. We will set the host name that we want to use, and we will configure the backends. The backend, we already deployed the backend under this name, and we will say which port should be used and specify the path. The path type is mandatory in the latest version, and in this case, I will use the exact. So it's also created. If we check the status, our pods are running and the service is in there. So to test that, I need to add this domain to my host names. And I will use the IP of the load balancer. And we are coming to our website. It is the same also for the Windows. First, we need to deploy the services. Of course, I need to download the raw. So the services are created. Now we are going to deploy the Ingress controller for this one. Our host name is this. It's created, and if I set this host name, I will be able to call that also. And it's working. So our Ingress setup is working, and next section we will see how to manage and handle the certificates for our cluster. We will use the self-signed certificate in this case. When your cluster grows and you have more and more services in there, it will be really hard to maintain the certificates for the server. One option is to use the Cert-Manager. It has a really good support for different providers. You can check the documentation for that, and you will see the supported provider and different configuration for them. In this case, we are going to just use some simple self-signed certificate for our case. So for the installation, you can use the installation like this, But currently there is a problem with the Cert-Manager YAML, and it doesn't have OS selector. So if we try to use this in our cluster, it may fail because it will try to deploy the Cert Manager pods on the Windows machine, and it won't work. I have already adjusted this file, and you can find it in the repository. And for the installation, I will use my version. So we can download the modified version like this. And afterwards, we can just apply it. And we will check the Cert Manager namespace. So the pods are running. Yep, now everything is ready. So for working with the certificate, first we are going to create the one CA certificate, and afterwards we use this CA certificate to create other certificates. So to create the CA certificate, we have defined the certificate like this. The SCA is true, and we have defined one issuer, and we use this issuer to create this CA certificate. So now, if we check the certificate, we have our issuer, and we have our certificate in there. You can also check the secrets. And that is the secret, which includes our certificate keys. So in the next step, we are going to define another issuer, which uses this certificate to issue which is this CA certificate to issue new certificates. So the new issuer is there, and status is ready. So it's now we can use this issuer to create the SSL certificate for our websites. So we have two other versions of the Ingress, and in these versions we are going to use the Ingress in conjunction with the Cert-Manager to create the SSL certificate for these websites. So now we are going to apply that. So now if we go back to the Linux web and try to refresh it, of course you will get the certificate error because the CIA is not trusted. But if you check the certificate, you will see that is issued to the Linux web. You can export the CA from the servers and copy it to other clients. So we will check the certificates. We have the CA certificate, and this is the new certificate that is created for our Linux app. And we need to export this certificate from secrets. That means if I check this, we say the CA and also the TLS keys and the TLS certificates and other specification for this for these certificates. The Kubernetes will save the certificates inside the secrets. So when we need to export them, we need to use them. So to export it, it will export the PEM certificate, or better to say, it will extract the PEM certificates from the secret. And now we can use the OpenSSL to convert it to the CRT for the Windows. So it has been exported. Now I can copy it to my Windows. And I'm going to install this inside the trusted root certificates. So now if I call this again, it is trusted and you have a valid certificate. To test it, we can deploy also our Windows app and use the same CA. We need to just configure the Ingress for the Windows app to use the SSL. And we use the same certificate issuer, so it will use the same CA. And now when we go to the Windows and refresh it, it has a valid certificate, and yeah, everything works fine. For the Cert-Manager, you need to pay attention to the documentation. When you want to use the issuer, and your other resources should be in the same namespace. You can configure extra attribute for your certificate with this annotation if you need them. For example, if you want to use the certificate authentication between the client and server, you can use this attribute to define the usage and so on. The other option is to use a cluster issuer, as you can see in here. In our case, we use the simple issue, which is configured in our namespace to create the certificates for the apps inside this namespace. So that's it. I hope you find the video useful. Thanks for watching and see you soon.